Small signal measurement is a common application for a spectrum analyzer. The smallest signal that can be detected depends on the displayed average noise level, or DANL, of the instrument. This video will show us how to reduce the DANL so that we can measure small signals. Let's start by configuring a function generator like the Regal DG4000 series to output a 20 MHz minus 50 dBm sine signal. Then let's connect it to the RF input of the Regal DSA815 spectrum analyzer. The factory defaults of the spectrum analyzer give a DANL of about minus 55 dBm. If we tested the signal in this condition, it may be lost in the noise floor of the spectrum analyzer. But we can adjust some settings and try to get a better DANL. You may recall that the DANL is related to these settings: the preamplifier, the attenuator, the resolution bandwidth, or RBW, and the video bandwidth, or VBW. Setting proper parameters can reduce the DANL and increase sensitivity to these low-level signals. Let's adjust the spectrum analyzer. Press Frequency and set the center frequency to 20 MHz. Press Span and set the frequency span to 10 kHz. Press Amplitude and set the reference level to make the signal display on the screen. Set the internal attenuation to 0 dB. Enable the preamplifier. Press the bandwidth detector key and set the resolution bandwidth and video bandwidth to 100 Hz. Now we can see the signal trace we want to test. Also, we can press the peak button. The analyzer will now search the peak values automatically, mark it, and display the frequency and power value of that peak point. To lower the DANL and make small signal measurements, we want to set a suitable frequency and amplitude scale to see the signal trace. We want to enable the preamplifier. We want to set the attenuation to 0 dB, reduce the resolution bandwidth and video bandwidth values, and use the peak function to read the signal frequency input.